Alright, in this video, I want to show you how to write net ionic equations. So it's pretty simple, but we need to first start by writing out a reaction just like we normally would throughout the year. So for A, I was given zinc nitrate. So zinc nitrate is ZnNO3, 2, plus ammonium sulfide, which is NH4, 2S for ammonium sulfide. Now we're doing double displacement, so it's outside things and inside things go together. So zinc's going to go with sulfide, and ammonium's going to go with nitrate. Now I've crossed their charges and taken care of all of that already, but make sure that when you're writing out the reaction that you take into account for any charges that these things have. So I need to balance the reaction next, so I need a 2 in front of those. And now here's where the new stuff starts. So I have to check to see if these are aqueous or if they're a solid. So I need to know if they dissolve in solution. So I need to check my solubility rules. So if you look at zinc nitrate, any nitrate compound is soluble. So I'm going to write aqueous. Same with ammoniums. They're aqueous. Sulfides are not, so that would be a solid. And then ammonium nitrate would be aqueous. Okay, so now we're going to write the complete ionic equation. So to do that, if it says aqueous, if it's a strong ionic compound or a strong electrolyte, so that includes soluble ionic compounds or strong acids or strong bases, then I break it apart because it dissociates in solution. If it is not one of those, if it's a solid liquid gas or a weak acid or a weak base, then I don't dissociate it. So for this first one, it's aqueous, so that is a soluble ionic compound, so I break it up. So I have one zinc, so I write Zn with a 2+ charge, and it's aqueous. I break up the nitrates, so I get 2 NO3s, and they're aqueous. I'm just carrying down the state of matter from the top. Plus, I have 2 ammoniums, so 2 NH4s, plus, and they're aqueous. I have a sulfide that's 2-, and that's aqueous. Yields zinc sulfide, which is a solid, so I don't break it up, just leave it go. And now I break up the ammonium nitrate, so I get 2 NH4s, plus, they're aqueous, and I get 2 nitrates, which I'm going down the side here, but that's okay. So now, I want to check to make sure, or I want to check for spectator ions. So they're ions that don't participate in the reaction that I can cancel off. So I look at zinc 2+, and if I don't see it on the other side, over here anywhere, exactly the same, then I don't cancel it. So I don't see zinc 2+ over here, so that's not a spectator. But I do see 2 nitrates over here and 2 ammoniums over here. So since they're the same on both sides, I can cancel those off because those are spectator ions. They don't actually react, they're just there. So now I write what's left over. So that would be zinc 2+, aqueous, plus sulfide 2- aqueous, makes ZnS, zinc sulfide. And that's it. That's my net ionic equation for the first one. Okay, so let's take a look at the second one. So I was given potassium chloride, so that's KCl, and that is aqueous for my solubility rules. Calcium nitrate, which is CaNO3, which is aqueous from my solubility rules. Now I'm going to use double displacement. So K is going to go with NO3. And that is aqueous with my solubility rules. And I get calcium chloride, which is aqueous according to my solubility rules. So all 4 came out as aqueous, which means if I write the complete ionic equation, everything's going to cancel off. So let's take a look at that. So I would first need to balance this. So let me move this over. So that would be a 2. So I would get 2 potassiums that are aqueous, and 2 chlorines, which are aqueous, plus a calcium, 2+, aqueous, and 2 nitrates, aqueous, yields KNO3, 2 in front of that for balancing, K plus, aqueous, plus 2 nitrates, plus calcium, and 2 chlorines, aqueous. And you notice everything cancels. I have my 2 potassiums, my 2 chlorines, my calcium, and my nitrates. I'm left with nothing. So that means no reaction actually happened. So let's let you guys try a couple. So pause the video, try these 3, and then when you come back, I'll run through how to do them. All right, so there's the first one done for you. So I wrote out potassium chloride right here, and it would be aqueous according to my solubility rules. Same with silver nitrate, potassium nitrate, and then silver chloride is going to be my solid. So if it says aqueous, I dissociate it into its individual ions. Same with this one, same with this one. And then all I'm left with is the solid, which I can't dissociate. Cancel the things off that are the same on both sides, and then write what's left over, and that's my net ionic equation right there. Okay, so try the second one, pause the video, and I'll come back and show you that one. All right, and there's the second one. So I have my normal complete balanced equation at the top here, and I took my solubility rules into account. I broke down all the aqueous stuff. This was a solid. And then I canceled off my spectators. So all I was left with was that right there. So try the last one, and I'll show you how to do that one. All right, so this one's a little special of a situation because I write out my balanced reaction, and all 4 of these come out as aqueous. So if I would break them all up, they would all cancel. So when they all come out as aqueous like that, no reaction has occurred. So that's all I would write for that one. So be really careful with that. It's not always no reaction, but if they're all going to cancel off, like in this situation, nothing actually would occur. So that's how you write net ionic equations. So if you have any questions, just let me know in class.